Hey everyone! Today, we're going to learn how to change a quadratic equation from one form to another. Now, I know that might sound a little intimidating, but it's a really useful skill in algebra, and I promise we'll go through it nice and slow, step by step.
Welcome once again to our Special Needs Corner. So, what's our main goal for today? Well, it's pretty straightforward. We're going to take an equation that's in what we call vertex form and transform it into its general form. Now, you might be wondering, why bother? Well, think of it like an equation changing its outfit. Each form tells us something different and useful, and even though they look totally different, they actually represent the exact same function.
All right, let's jump right in with our first example. This one is perfect because it's going to walk us through all the basic core steps of the process.
Okay, so take a look at our first problem. We've got y equals, in parentheses, x minus 3 squared, and then a minus 1 at the end. Our mission is to rewrite this thing, and we're going to do it one piece at a time.
First things first, we've got to deal with that little squared symbol. Now, what does it mean to square something? It just means you multiply it by itself. So x minus 3 squared is really just a shorthand way of writing x minus 3 times x minus 3. Easy enough, right? Okay, for step 2, we're going to use a super handy method called FOIL to multiply those parentheses. If you haven't heard of it, FOIL just stands for first, outside, inside, last. Let's do it together. For first, we multiply the first terms. X times x gives us x squared. For outside, we do the two outer terms. X times negative 3 is negative 3x. For inside, we do the two inner terms. Negative 3 times x is another negative 3x. And for last, negative 3 times negative 3 gives us a positive 9.
So after we've done our FOIL magic, this is what the equation looks like. Now take a close look at those two terms right in the middle. See how we have a negative 3x and another negative 3x? Since they both have an x, we call them like terms, and that's our cue that we can combine them.
So our next logical step is to combine those similar terms. What's negative 3x plus another negative 3x? You got it, it's negative 6x. Look at that, our equation is already looking so much simpler. We are almost there with this one.
We have just one last little bit of tidying up to do. Look at the very end of our equation. We have two plain old numbers there, a positive 9 and a negative 1. These are our constants, and just like we did with the x terms, we can combine these guys too.
And here we have it, our final answer. 9 minus 1 is 8. So our fully transformed equation is y equals x squared minus 6x plus 8. And just like that, we've successfully changed it into general form.
So let's do a quick before and after. On the left, that's where we started, in vertex form. And on the right, that's our beautiful final answer, in general form. They look so different, but it's crucial to remember they are just two different ways of writing the exact same thing. All right, fantastic job on that first one. You ready for round 2? Let's try another example. This one builds on what we just learned, but it adds one important new step into the mix. Don't worry, we're going to use the same process.
Here's our new problem. Notice anything different about this one? Yep, that's right. There's a big 2 sitting right out front, outside the parentheses. We call that a coefficient. We're going to follow all our steps just like we did before, and we'll deal with that 2 in just a little bit.
And check this out. Our first 2 steps are exactly the same as before. See the pattern? First, we expand x plus 5 squared, which just becomes x plus 5 times x plus 5. Then we use our trusty FOIL method on those two. That gives us x squared, plus 5x plus another 5x plus 25, all still inside the parentheses. Just like last time, we're going to look inside those parentheses for any similar terms we can clean up. And yep, there they are. We have a plus 5x and another plus 5x. When we combine them, we get plus 10x. A good rule of thumb is to always simplify what's inside the parentheses first. Okay, here it is, our new step. It's finally time to deal with that 2 that's been hanging out in the front. This step is called distribution, and it just means we need to multiply the 2 by every single thing inside the parentheses. So we're going to do 2 times x squared, then 2 times 10x, and finally 2 times 25. So what does that look like after we distribute? Well, 2 times x squared is 2x squared. 2 times 10x is 20x, and 2 times 25 is 50. The parentheses are officially gone now, and we are on the home stretch. And for the grand finale, our very last step is the same as it was in our first example. We just need to combine the constant numbers at the very end. 50 plus 3 gives us 53. And there we have it, our final answer. 2x squared plus 20x plus 53.
Fantastic work, everyone. Let's take a second to do a quick review of everything we just learned.
So here's a little summary of our two problems. In both cases, we followed the same clear pattern, right? First, we expand the squared term. Second, we use the FOIL method. Third, we combine the similar x terms. And then sometimes, like in our second example, we have to distribute that number out front before we do our final simplification. It's a reliable process you can use every single time.
Thanks for watching. See you next time.